Alright, welcome back everybody. Ex Phys Guy here. We're going to be talking about electrocardiogram leads today. Electrocardiogram can be abbreviated either ECG or EKG. In some of my other videos I went over cellular depolarization to stimulate an electrical impulse, and I did go over an introduction to EKG. Some EKG stuff. I do like to go over the leads first before I go over things like QRS morphology or getting into how we measure the different waves. So real basic to start off, when you measure a 12 lead electrocardiogram, you're measuring exactly that. You're measuring 12 leads, or 12, if you would, quote unquote, views of your heart, and those are going to be labeled as your lead 1, 2, 3, your AVR, AVF, and AVL. Now those are also what we call limb leads. So when we connect the EKG, those leads are going to go on the left wrist, right wrist, and then the left and right ankles. But a lot of times we do a modified setup where we just do the limb leads. We do them one right below the right collarbone, right below the left collarbone, and then we do some just at the base of the lower abdomen on either side. You can do that too. It's just a modified version. The chest leads, or the precordial leads, are labeled as V1, V2, V3, V4, V5, and V6. Now the major difference between the limb leads and the precordial leads is that the limb leads, in a sense, give you almost a two-dimensional view of the heart. So if you look down at this green triangle, they give you a sense of the electrical impulse basically from the top to the bottom. Top to the bottom. They don't really give you the view of, so say, if you have a lead V5 that's placed somewhere in between fourth and fifth intercostal space on like the mid-axillary line, you're not gonna get that kind of view from a limb lead. You'll get that from a lead V5. So they're much more specific, and I'll go over those in a separate video. But to understand what an electrocardiogram does, you really have to understand what it's recording. It's recording the electrical impulse that is stimulated or started at the SA node. Now, when that electrical impulse is started, it travels basically from the SA node, which is at the base of the heart in the right atrium, and it's going to travel down through the heart into the left ventricle. So essentially, like this. All right. And that's that's what shows up. So if you look up over here, that's what shows up on your leads. Now, lead 1 is going to measure the difference. So if you look at this triangle, you have lead 1 up here, lead 2, and lead 3. Each limb has, or each lead rather, has a negative side. I got erased over here, but these are both negative. So these are negative ends. So lead 1 has its negative end on the right arm and its positive end on the left arm. So when we look at lead 1 on an EKG, we see all positive deflections. Now let's focus, or positive inflections. So let's focus on the QRS. So that's depolarization of the ventricle. So if we came over here to the triangle, we should see a signal that goes something in this area because it's traveling mainly towards the positive end of the lead 1 lead. Same thing with lead 2. If we go over 2, QRS is positive. The signal is going to travel like this towards lead 2's positive end. So lead 2 measures from the right arm down to the leg. Okay, and lead 3 is going to measure from left arm down to the leg. So these should all be positive. Or truly, lead 3 should be biphasic because the electrical impulse is traveling perpendicular to the positive end, which would be here and here, down here. So it's traveling perpendicular to lead 3's positive end, which is over here. So that's if we had a 100% textbook example. That is what it would look like. Now there are other leads, other limb leads, these augmented leads, these AVR, AVF, AVL. For exercise physiologists, these leads are really not used that much, really at all. AVR can be helpful during setup because AVR is a ground lead where the negatives are on the opposite end of the leads 1 and 2. So because of that, if we see something in AVR that looks a little off, we can say, oh, maybe these leads are not set up correctly. So in other words, AVR, usually everything should be upside down. These should all be upside down. So if they're not, number one, you always want to go and make sure they're set up properly. So if they're not, chances are you have one of these limb leads not put on properly. And this diagram over here is really where we're going to understand the most about the leads, and I'm going to just zoom in on it right now. Okay, so this is the hex axial diagram that you're looking at. This is a graphic representation of your 3 limb leads 1, 2, and 3, and your augmented leads AVR, AVF, and AVL. Now, any dotted line is a negative end or a negative pole. I forgot the negative in front of AVL, but this should be negative here. Any solid line is a positive end. So in other words, imagine the right atrium, the base of the heart right atrium is somewhere up here, and the SA node is somewhere up here. The normal electrical current should travel down this line towards the positive end of lead 2. And if it does in fact do that, then what it should give us is a reading that looks something like this. Okay, a positive QRS complex. This should come all the way down. I don't want there being any ST segment elevation or anything like that. But yeah, so basically what that is showing is the signal is traveling towards the positive end in lead 2. Now, if we were to look at lead AVR, and we had a normal electrical current traveling down this pathway, what we should see in lead AVR is we should see negatives. We should see everything being negative, right? Because the electrical current is traveling towards positive end of lead 2, but the negative end of lead AVR. So that's how you can tell if maybe something is not set up properly. If you see positive inflections in lead AVR, that's not normal. Either it's set up incorrectly, or we have a really, what is called axis deviation. We have a really skewed axis deviation. And I didn't want to get into that in this video, but basically the normal axis, so the normal bulk of the electrical current of the heart should be anywhere in this area. Anywhere from this positive end of lead 1 to the positive end of lead 3. And there's some measurements in there, which I'm going to do in a different video. But you can have normal axis deviation, you can have left axis deviation, you can have right axis deviation, or you can have extreme right axis deviation. I think that's still the nomenclature that they use. But the hexaxial diagram, specifically for exercise physiologists, definitely something you're going to want to remember. It's going to be vital when it comes to EKG interpretation. The take-home point here from these sets of videos is I want you guys to understand electrical current, the travel of electrical current, the positive end of an electrode, the negative pole or end of an electrode, and what that means. If the electrical current, so our wave of depolarization, right, our electrical stimulus, if it's traveling in its normal direction, the bulk of those, the sum of all the electrical current should travel this way. Remember that triangle? It should travel this way. And if it does, we'll see positive deflections in lead 2. So which means we should see biphasic in lead 3 because it's traveling perpendicular to this lead 3. And I will get over some of those examples in some different videos, but I hope this was a good introduction to some of the electrocardiogram information and what your normal EKGs should look like. The limb leads are number 1, 2, 3, AVR, AVF, AVL, and your precordial or chest leads, V1 through V6. There's a triangle, and there's what your normal leads 1, 2, and 3 should look like. All right, thanks for watching.